In this video, we're diving into the symptoms of a bad throttle position sensor, or TPS. A throttle position sensor is an essential component in the engine's electronic control system, monitoring the position of the throttle valve in the throttle body. Positioned on the butterfly spindle or shaft, it directly measures the throttle angle, the rate at which it opens and closes. The TPS measures real-time throttle position data to the engine's ECU. This information, combined with inputs from other sensors like the MAF and MAP sensors, helps the ECU calculate air density entering the engine. This data is crucial for determining the optimal timing for injector opening and adjusting the spark advance, ultimately ensuring that the engine maintains the ideal air-fuel ratio of 14.5:1 for efficient combustion and performance. The throttle position sensor is typically located on the throttle valve spindle, which is part of the throttle body. The throttle body itself is positioned between the air cleaner and the intake manifold of the engine. The throttle body itself is positioned between the air cleaner and the intake manifold of the engine. A malfunctioning TPS can manifest in various symptoms, indicating potential issues with the vehicle's engine performance. Let's explore the symptoms of a bad throttle position sensor one by one. The number one symptom is illuminated check engine light. A malfunctioning TPS can trigger the check engine light to illuminate on the dashboard. The number two symptom is error codes. Malfunctioning TPS may trigger the OBD2 code related to a bad TPS upon scanning. Later in this video, we'll discuss common trouble codes associated with a bad TPS. The number three symptom is rough running or hesitation. With a faulty TPS sensor, the engine control module may not receive necessary sensor data related to the vacuum of the intake manifold to maintain the air-fuel ratio at 14.7:1. This can result in rough running or hesitation, impacting the engine's overall performance. The number four symptom is visible exhaust emissions. Visible exhaust emissions may be observed while driving due to a lean or rich air-fuel mixture resulting from the faulty TPS. The number five symptom is engine stalling. Intermittent engine stalling may occur due to a faulty TPS. The sixth symptom is lack of power. Lack of power during acceleration may occur due to the faulty TPS, which affects the engine air intake system, leading to inadequate or excessive air supply to the engine. The seventh symptom is poor fuel efficiency. Inefficient fuel consumption may be observed as a symptom of the faulty TPS, as it affects the proper regulation of the air-fuel ratio due to the absence of sensor data. This can result in the wastage or improper utilization of fuel. A malfunctioning TPS sensor can trigger OBD2 codes. Here are some common error codes related to a bad TPS. Number one, P0068, which indicates MAP-MAF throttle position correlation. Number two, P0120, which indicates throttle position sensor circuit malfunction. Number three, P0121, which indicates throttle position sensor circuit range problem. Number four, P0122, which indicates throttle position sensor circuit low input. Number five, P0123, which indicates throttle position sensor circuit high input. Number six, P0124, which indicates throttle position sensor circuit intermittent. To diagnose the faulty TPS issue, you need to ensure that a faulty TPS is the root cause. To confirm the TPS is functioning properly, the TPS needs to be tested. There are different ways to test a TPS. The first test method is to check voltage using multimeter. In this method, we measure the voltage of the TPS output using a multimeter. The sensor's power supply is provided with the car ignition in the on position. Follow these steps to test correctly in this method. The first step is to set the multimeter to voltage mode. Then connect the red probe to the signal wire of the TPS connector. Remember, the signal wire is usually the one in the middle, but it's always a good idea to double-check with your vehicle's wiring diagram to be sure. Now take the black probe of your multimeter and connect it to a reliable ground point. like the battery negative terminal or the engine block. Next, turn on the ignition key without starting the engine. This allows power to flow through the TPS for testing while keeping the engine off. Finally, check the voltage reading on the multimeter. Typically, the voltage should read between 0.5 and 1.5 volts. If the voltage falls outside of this range, it indicates a faulty TPS that needs replacement. The second test method is to check resistance using a multimeter. In this method, we measure the resistance of the TPS sensor. Follow these steps to test correctly in this method. The first step is to switch the multimeter to the resistance mode. The second step is to connect the probes of the multimeter to the power and ground wires of the TPS connector. Typically, the power wire is red and the ground wire is black, but refer to the wiring diagram to confirm. The third step is to ensure that the ignition key is turned off to prevent any electrical interference. The fourth step is to measure the resistance between the power and ground wires. The multimeter should typically read between 200 and 600 ohms. If the resistance falls outside of this range, it indicates a faulty TPS that requires replacement. When a car exhibits the symptoms mentioned above, and the TPS has been checked and found to be in working order, but the issue persists, it's essential to inspect the other components of the air intake monitoring system that exhibit the same symptoms of bad TPS. Issue number 1 is the faulty mass airflow sensor. A defective MAP sensor can produce similar symptoms to those of a bad MAF sensor. The MAF sensor is responsible for measuring the mass of incoming air and plays a crucial role in determining the air-fuel mixture ratio. The number 2 issue is a faulty manifold absolute pressure sensor. A defective MAP sensor can produce similar symptoms to those of a bad MAF sensor. The MAP sensor measures the pressure within the intake manifold and assists in determining the air-fuel mixture ratio.